MS Ramaiah University of Applied Sciences.
Hi students, today we will perform the time response analysis for a second order system. Consider a second order system given as C of s by R of s is equal to omega n square divided by s square plus 2 zeta omega ns plus omega n square, where zeta is the damping ratio of the second order system and omega n is the undamped natural frequency of the second order system. Now let us simulate the above given second order system by assuming the values of zeta and omega n. So zeta is 0.1 and omega n is 2. By substituting we get this transfer function. Now in the MATLAB platform, in the command window, we will write the coefficients of the numerator as NUM is equal to, open the square brackets, 4, close the square brackets, enter. Now let us define the coefficients of the denominator. Denominator is equal to 1, 0.4 and 4 are the coefficients of the denominator. Press enter. Now let us define a system as the transfer function of numerator and denominator. Press enter. Now we can see the same transfer function as we had developed in the previous slides. Now we will analyze the transfer function by giving a step input to the above obtained system. Press enter. So here is the response of the system. If we click on the graph, we can get the information regarding the time amplitude for the system response, which is analyzed with respect to time. Now right click and press grid. You will get the grid on the response. Now type hold on to add more values for zeta and omega n without change in the program. So we will change the zeta value as 0.5 and omega n will retain it as 2. So the second order system is being changed. Now again define the numerator coefficients. Press enter. Now define the denominator coefficients with a different name as denominator 1. So the coefficients are 1, 2 and 4. Press enter. Now define the system as transfer function of numerator 1 and denominator 1. Press enter. So this is the continuous time transfer function what we had obtained after changing values. So analyze the system with a step input. Press enter. You can see there is another graph for the second system which we had defined by changing the values of zeta and omega n. So now this graph is obtained in green color. Now we will change the value of zeta as 0.8. Now again you can see the change in the transfer function. Now define the numerator coefficient as NUM2. Enter. Denominator coefficients as 1, 3.2, 4. Enter. Now define the second system as transfer function of numerator 2 and denominator 2. Press enter. You can see the changed transfer function of the new system. Now analyze the system with a step input. Press enter. You can see another plot or the response given in red color in the same graph. Now we will increase the zeta value to 1. So you can see the change in response. Now again define the numerator coefficients and also define the denominator coefficients enclosed within square brackets. Press enter. Now define the system as transfer function of numerator 3 and denominator 3. Press enter. So this is the new transfer function by substituting the value of zeta as 1. Now analyze the system with a step input. Press enter. Now you can see another graph indicated in blue color. So now you can zoom the response. You can have a clear picture of the response with changing value of zeta. Now we'll use the properties of the graph. Type legend. Type inverted comma and enter the various zeta values enclosed within inverted comma as 0.1, 0.5 and separate each value with a comma. 0.8, 1. Press enter. Now you can see there is a change in the graph. In the right corner you can see there are the legend is being included in the graph. For varying values of zeta, the colors is being indicated. So now we can note the peak time for each curve for varying values of zeta just by clicking on the plot. So these are the various peak time for different values of zeta. So this is a standard step response wherein we can see the rise time, peak time, delay time, peak overshoot, settling time. This is the delay time. This is the rise time, where it is the time required to reach the unit step. This is the peak time. It is the time taken to reach to the peak of the response. So this is the tolerance, allowable tolerance for the settling time. And from 0 to this point is the settling time. So these are the various formulas which are used to calculate the rise time, which is pi minus theta by omega n root of 1 minus zeta square, peak time, settling time, and for both 2% and 4% tolerance, and this is the maximum overshoot formula, and this is given as in percentage. Now the same MATLAB code can be written in script file also. Initially we had written it in command window. Now we will be developing the same model using Simulink. So for that, open the Simulink model page, and then you will have to click on view and select Simulink library browser. So this is the library browser window. So here there are various blocks available. Go to continuous. Include a transfer function block in, drag and drop the block. Then select sources. In that, go for step input. Drag and drop the step input in the Simulink model page. Then go to sinks, select scope, again drag and drop the scope. Now connect the step input to the transfer function, and from the transfer function connect it to scope. Now double click on step input. You can see there are various parameters. Make step time as 0. Press OK. Now double click on the transfer function block. You can see the numerator coefficients. Now change it to 4, and in denominator coefficients change the values for your obtained transfer function denominator coefficients. Apply and then press OK. Now your system is ready. Now press the run button. Now double click on scope. You can see there is a new window with the output. Now we will have to go for the axis properties and zoom in for the required response. Now again double click on transfer function, or you can drag and drop for another transfer function to be added for different value of zeta. Now I'll change the value as 2. I'll apply, I'll press OK. Now give a step input to the second transfer function. Now go to signal routing. There select mux, drag and drop on your model page. Now connect all the transfer functions, both the transfer functions, to mux, and from there give the input to the scope. Now run the system, double click on scope. You can see there is another response for the second transfer function what we had selected with the changed value of zeta. Now double click on mux. You can change the number of inputs based on your requirements. Now I'll make the input as 4. So you can see there are 4 inputs to the mux. Now again consider another 2 transfer function blocks. Now double click on each and change the values of zeta. Press OK. Now go for this other transfer function block. Change the value of zeta. Press OK. Now for each transfer function block, give the step input, and again from the output of the transfer function connect it to the mux. Now run the simulation. So there are 4 transfer functions. we can rename the transfer function as zeta with various zeta values. So the first transfer function is for a zeta value of 0.1. The second transfer function is for a zeta value of 0.5, and the third transfer function is for a zeta value of 0.8, and the fourth transfer function is for a zeta value of 1. Now run the system, double click on scope. You can see that there are 4 plots. So here for various values of zeta there are different graphs. Now double click on scope, go to settings, check legends, put a tick mark in legends box, press OK. You can see that there is a legend on the right corner with various colors for different values of zeta. Yellow is for zeta 0.1. Thank you.
At MSR UAS, we spark your imagination unlike any other.